Hey everybody, this is Larry. This is day 4 of the April Legal Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's forum, and we're gonna have another linked list forum. I feel like we've done this one recently, or maybe some variation of this one. I mean, I guess it's probably in a variation. So we're only swapping 2 nodes, right? Is that it? And we only have to swap the values. So it actually doesn't look like we have to actually swap the nodes themselves, though. If you're willing to practice, maybe do it. I would also say that I think there are a couple ways you can do this, right? The idea is having a one kind of cute way that I remember from last time of doing this, but I didn't do it that last time. Is that there's a cute way to get the cave node from the end by having like a I wouldn't say fast, slow pointer, but it's not. They're moving at the same speed, but one pointer that's ahead, and then another one that is not. Because you can have one that is k node ahead, and then by the time, and then now you move to the end, and then when you get to the end and at the earlier one, then you would and the node that is behind would be k node from the end, and then there you just run another second node or third pointer or whatever from the beginning and then swap the values. And that should be good unless I'm misunderstanding this problem altogether. Right, 2, 3, 4. We swap this one with this one, right? That's it. I think that's only okay. Yeah, okay, so let's do that then. I mean, I think you can also, if you're really lazy, just kind of do it, or not lazy, but I think this is the way that I would have done it, just because it requires less thinking. And I think sometimes, especially in engineering, you can definitely be too clever without needing to, right? So the way that I would actually do it is probably just count the number of nodes and then do the math and then just do it that way. But this time we have some time, so let's try to upsolve it a little bit by being a little bit clever and playing around with that. So yeah, so let's just say, yeah, okay. So let's say ahead is equal to head, behind is equal to head, and then we move like something like that. And then now we keep on doing while ahead is not none. Oops. And then now when this loop is done, behind will be at node k. It could be off by 1, so I'm going to just run this really quickly to make sure that that's the case. Yeah, so for example, this is 4, this is 8, so yeah, so we look like we're good here. And then now we want another one that's k ahead. So let's start from beginning again. And then now we can swap. I mean, I'm gonna print out the values just for debugging purposes, but otherwise we should be able to just swap it really. And then return the head. Yeah, okay. Oh, did I mess this up? 1, 2, 3, 4, 5. Yeah, I think that's the thing. That's why I usually oh, it's one index. That's why. Okay, so this is one index. Then we only move this one. This is weird. Then I think this one is off by 1 then, but maybe not. And now let's actually do a couple more. I mean, the numbers don't actually matter. It's just about the k, I think. So let's try this. Can k be 0? No, k has to be. So we can try this for pretty much all the numbers. And then maybe try one more or one set more for odd numbers or odd length. linked lists. And I think we should be able to give it a spin and maybe get rid of the print statement for obvious reasons. But okay, so with that looking good, let's run it again so that we get rid of the print statement, or making sure. I'm very careful, I suppose. And then now we can give it a submit. It feels like, I mean, this was a year ago, but it feels like yesterday, I suppose. This time, okay, a little bit faster, I guess. I don't know. There's some stuff about location locality what I did last time. Yeah, so last time I got the N. The time before that, no, I put it into a way. Well, and this time I think I did it the intended way. So yeah, cool. I think that's all I have for this one. It's gonna be linear time because we just have a couple of for loops and looping them. So yeah, and all of one space because we don't really store anything. So yeah, let me know what you think. Hope y'all have a great week. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.